Okay, so I'm going to do this last question from yesterday. So it's 2 cosecant squared plus cosecant x minus 1. Now, I'm going to show you 2 ways. One is by factoring. Hello? That's why I get worried every time somebody asks me. Anyone else not get a sheet? I'm very sorry. Okay. We're good now? Okay, so I decomposed 1 into 2 and minus 1 because I'm looking for 2 numbers that multiply to give me minus 2 and add to give me positive 1. Okay? From here, I can take out 2 cosecant x multiplied by 1 cosecant x plus 1 minus 1 times cosecant x plus 1 equals 0. So now I have a common bracket. When I have 2 things that are multiplying to give me 0, each of them could be 0. So once you come to this point, your next thing is cosecant x plus 1 equals 0. 2 cosecant x minus 1 equals 0. And then you go ahead and solve that. So cosecant x equals negative 1. But cosecant x is 1 over sine x. So essentially, if you flip both sides, sine x is equal to negative 1. Now they gave us the domain of x. They said it was 0 to 2 pi. Sine x will be negative 1 when x is equal to 3 pi over 2. So that's for this side. For this side, you have 2 cosecant x equals 1. Cosecant x equals 1 over 2. 1 over sine x equals 1 over 2. So when you flip both sides, sine x is equal to 2, which is nonsense. So that's how you do it using factoring. Okay? That's one way. The other way is to look at this equation and recognize that it's a quadratic with coefficients 2, 1, and -1. So cosecant x will be negative b, b is positive 1, negative b, plus or minus b squared minus 4ac, all over 2a. So that's -1 plus or minus 3 over 4, telling us that cosecant x could be -1 plus 3 over 4. That's 2 over 4, 1 over 2. Or cosecant x could be -1 minus 3 over 4. So -4 over 4 minus 1. You can see the same two setups over here. When you solve for it, whether you use quadratic formula or you use factoring, you still have to go through the next process of saying 1 over sine x equals 1 over 2 sine x equals 2, reject. 1 over sine x equals -1 over 1 sine x equals -1. For those of you who are like, how do you get 3 pi over 2? Look at your unit circle, look at the y coordinates and the x coordinates. You're looking for -1 in your x coordinate. And you'll find that, -1 in your y coordinate, because you're looking at sine. So when you look for -1 in your unit circle, you should be at 3 pi over 2. Look for -1 in the y value. For sine, you're looking for the y coordinate, cosine, you're looking for the x coordinate. So there's two ways, right? That's why I didn't want to rush it yesterday, and I wanted to show you the fact that, sine x can never be 2, because the max is 1 and the min is -1. So it's always going between 1 and -1. So sine and cosine can never be outside of the range of -1 to 1. Tan is a different story. So we have quite a few questions to finish today and tomorrow, because I'd like you to, so that next week we can spend more time getting ready for the test. You've got today, tomorrow, and you've got the PA day. For your homework questions, I think I've put them on the sheet. I just want to make sure that we're clear. You're doing 1, 3, 5, 7. And I just took out the technology questions. And then after that, we're pretty much going through all of the equations. Okay. Okay, I'm going to start. I'm just going to go through the first question, a couple of examples. So it's approximate radians and it's not exact value. So I just want to teach you how to do that. And then I'll give you time to practice that. So if I do A, I could say that sine x minus 1 over 4 equals 0. Sine x equals 1 over 4. Now I know that x is going to be pretty close to pi over 12. because remember, pi over 12 is like 0.26 for sine. So the way you do this on your calculator is, please make sure that your calculator is in radian mode. And then on your calculator, x is going to be sine inverse of 1 over 4. Now we like to round radians to 2 decimal places. So I got 14.47 because I'm in degrees. So if I do 0.25 seconds sine, I got 0.25. This happens in radians. That's why it's fine. So x is equal to 0.25. So let me explain what this is saying. See how it's 0 to 2 pi? So here's my circle, right? It's helpful if you remember these numbers. 0, 1.57 pi over 2, 3.14 pi, and I believe it's 4.71. See 0.25? 0.25 is here, between 0 and 1.57. How much doesn't matter exactly because we're not measuring it. 0.25. So we've got cosine, all, sine, and tan. So we've got another positive sign in this quadrant. Are you with me so far? Who's not with me? So this part here, that angle is 0.25. So to find this angle, you got to do 3.14 minus 0.25. Let me write that smaller. Because this angle is 0.25. This angle will give you the same sign because of symmetry. This size is 0.25. So to find this angle, it's 3.14 it's 3.14 minus 0.25. Okay? So that's going to give us 2.89. There's no degree symbol because it's radians. The other tip off that it's radians is that it's 2 decimal places. Okay? So to believe what I'm telling you, if you took the sine of 2.89 or you took the sine of 0.25, you should get a quarter. Okay? I'm going to show you. This one's talking about exact solutions. This is a very useful one, so we'll solve that first. Cosine x minus 0.5 equals 0, which tells us that cosine x is equal to 0.5. So if you look at cosine, there are 2 points where it's 0.5. This one, this one. Because on this side, cosine will be -0.5. This is the only side where it's +0.5. The other way you know that is because you've got the CA of the gas rule. Okay? And we are looking for positive 0.5. So it's this angle and this angle. This angle is pi by 3. So how would we know that? Look at your unit circle. And in the x coordinate, because we're dealing with cosine, look for 1 over 2. So if you find 1 over 2 in the x coordinate, that angle is pi over 3. The other angle is 5 pi over 3. So you need to pay attention to the language. When they say exact solutions, they're looking for pi over 3, pi over 6, pi over 4, 7 pi over 12. When they say approximate, then you're looking for radians, 2 decimals. Okay. I think I lost 5. Let's do 5C. 5C says tan squared x minus this means tan squared x is equal to 1.44. So tan x is going to be plus or minus 1.2 times 1.2 will give you 1.44. Negative 1.2 times negative 1.2 will give you 1.44. This plus or minus is huge. This plus or minus, if you forget the plus or minus, you're going to miss half the answers. So it's a very big deal. Okay. So when you find out what this is, you're going to do x equals tan inverse of 1.2 and you've got x equals tan inverse of negative 1.2. I got 0.88. I'm going to show you how to interpret those and change them to your formal answer. So we've got 0.88 and we've got negative 0.88. Okay. So what happens is you've got so 0.88 would be somewhere over there because it's between 0 and 1.57. So we've got C, we've got A, we've got S, we've got T. That means tan will be positive in that quadrant. It will also be positive in this quadrant, right? So here's my other side. This is 0.88. This angle will be 3.14 plus 0.88 because we're going to go from here all the way to 3.14 plus 0.88. So you remember once upon a time you learned about the opposite angle theorem, which told you that when you have two cross lines, these angles are the same. That's why. Okay. But this is 0.88, this is 0.88. So this angle from here all the way to this point, starting there and going all the way to this point, will be 3.14 plus 0.8. Or 0.02. We go over here. This time they told us it's negative 0.88. Okay. So this we got to do a little bit of work with. Because our domain is 0 to 2 pi. But first, let's look at the other side. This is C, A, S, T. In this quadrant, it's negative. The other quadrant that it would be negative in is this one. Okay. First, let me show you the easy one. If this is 0.88, this is 0.88, negative. So this angle here is always go relative to the horizontal. Never, ever use the x-axis. Okay. So this angle is 3.14 minus 0.88. Put your feet up, guys. Asleep. So this one is 2.26. This angle here, remember this is 6.28, correct? So this second one will be 6.28 minus 0.88. Once you've done all of that nonsense, x equals 0.88, 4.02, 2.26, and 5.40. It's okay if you want to put them in order as well, but those are the four numbers that you're looking for. And if you put those into your calculator, all four of those values will give you a tan of 1.2. These ones will give you 1.2. These ones will give you negative 1.2. Okay. So we do an example of 7. Okay, 7 is exact. Let's do a tan. From 0 to 2 pi. Okay. So this tells me that tan squared x equals positive 3. And so tan x is equal to plus or minus radical 3. So tan is sine over cos. And the only way to wind up with that radical 3 on the top is if your sine was root 3 over 2 and your cosine was 1 over 2. Then sine over cos would be root 3 over 1. So what you're looking for is all of the points on your unit circle where your sine value is radical 3 over 2 and your cosine value is 1 over 2. So that should be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so if you look at your unit circle, you see this point and you see this point. Okay, and you've got this point and you've got this point. On this point, your tan value is going to be root 3 because your sine value is root 3 over 2. Your cosine value is 1 over 2. So when you do sine over cos, positive root 3. When you come to this point, your cosine is negative 1 over 2. Your sine is negative radical 3 over 2. So when you do this over this, positive root 3. So for tan x equals root 3, x is equal to pi over 3 and 4 pi over 3. For tan x equals, okay, now you see the difference of looking at the unit circle and memorizing where the different points are. Because if your head is like so much more powerful than looking at that sheet. If you can figure out those numbers in your head, for negative root 3, my cosine value here is negative 1 over 2. My sine value is root 3 over 2. So this will give me negative root 3. For this point, my cosine is 1 over 2. My sine is negative root 3 over 2. Negative root 3. So my x here must be 2 pi over 3 and 5 pi over 3. So you know what? I think that gives you enough to do 1, 3, 5, 7. And I believe you can try the other ones. And then whatever you don't get, even if you ask me for all the questions, we'll just work through them. We've got tomorrow. We actually have another 30 minutes, so I don't know how much more you guys can take. You know I'm mental, and I'll go to the next bell, but the only other one that doesn't look as simple is maybe 13. So let me show you 13, and the other ones are kind of run of the mill, okay? Am I in the wrong page? Okay. So 13a says sine 2x minus 0.8 equals 0. So 2x you got to make sure your calculator is in radian mode, and you've got 0.8 second function sine. I got 0.927, so 0.93. So if 2x is equal to 0.93, x must be, divide that by 2. So here's your circle. It tells you the domain for 2x is from 0 to pi. Okay? Which means the domain for x will be 0 to pi over 2. So you just got the first quadrant. 0.47. Is there any other quadrant in which sine is positive? Would you agree that it's in this quadrant? But that's out of our domain. Okay, so the only answer for us would be that one. The other way to do it is you've got 2x equals 0.93. Better make sure this is right. So here's my circle. This is 0. This is pi. This is 0.93. So 0.93 is maybe, this is 1.57. This is 0. So 0.93 might be over there. What other angle would give us a positive sign? Is it in second, third, or fourth quadrant? Second. So this angle here should be 3.14 minus 0.93. So my answer is between 0 and 3.14, which is pi. Do these two values fall in that range? So that means that 2x is 0.93 and 2.21. For x, you would divide both of them. One, 0, 5. So for 13, it's all calculator answers because they're not asking you for exact value. So that's the only key thing that you have to pay attention to. Is it exact value or is it approximate? Okay. If I did this one, so 2x would be sine inverse or 3/5. I got 0.64. So here's my circle. I'm only going, 2x is only going from 0 to pi. 0.64 will be somewhere over there. My sign is also positive in this quadrant. So that'll be 3.14 minus 0.64. So x would be 0.32 and 1.25. I'll leave C for you, and then if you don't get it, I'll take it up tomorrow. Because there's only one question like that. Okay?